here, Daniel, Farina, Eric Snyder, Sarah Torgerson, and we're presenting on green engineering. Our basic outline of what we're going to cover: what is green engineering, the Pollution Prevention Act, green chemistry, analyzing process flow diagrams, economic analysis of pollution, life cycle analysis, and conclusions. Green engineering. It's basically just the engineering of the environment. It basically is just designs that help to reduce emissions, eliminate hazardous chemicals, minimize the use of natural resources, and minimize energy use. The Pollution Prevention Act of 1990 made it so all companies were required to report their pollution prevention activities. They did this through a hierarchy of waste management. Source reduction, which was just, they modified their process so less waste was produced. Their in-process recycle, they tried to recycle unreacted feed in the process so they didn't have to use more than they needed or have more waste. On-site recycle, they converted waste generated into reactant on-site. Off-site recycle is separation of waste. They transferred it off-site and then converted it to a useful product in another area. The waste treatment was they couldn't do anything but produce that waste, so they would take it and treat it to make it non-hazardous or less hazardous. Secure disposal just includes securing it in an environment that's safe, landfills, security facilities. And then release to environment, they couldn't do anything with the waste, so it just went to the environment. They only consider the first two steps of the hierarchy as pollution prevention. The rest, they don't consider it. They just say these are the necessary steps if you cannot help either prevent waste from happening in your reaction or recycle unreacted feed. The top priority is to just not produce waste or to minimize the production of waste. The environmental fate of chemicals is always taken into consideration when they release it into the environment. They try to determine the effect these chemicals will have on the environment by looking at how the molecule is composed, breaking it down into its component parts, number of carbons, number of alcohol groups. Also, they look at the structure, such as aromatic rings, the branching, etc. Just, they want to make sure, or they want to look at how the molecule is going to affect the environment.
Section 2.5 was talking about green chemistry and finding how to find alternative feedstocks and green solvents, new pathways of synthesis so that you protect their environment through the ways you feed this process. You want the alternative feedstocks to be renewable, and so many designs are leaning towards renewable fuels like biodiesel and sun, as well as wind energy. The green solvents, you want them to be less toxic so that they hurt the environment, people, and anyone they come in contact with less. The synthesis pathways are just to avoid hazardous byproducts and side products. So as the reaction takes place, they want to find a different mechanism so that the so the byproducts aren't as harmful. 25.4 talks about pollution prevention during process design. What you want to do is you want to minimize your generation of waste products. So try to find how to make your system as efficient as possible. You want to design separation systems that recover as much of your material as possible. You want to minimize energy usage, and you want to minimize effluent streams containing waste. So all of that's pretty much the same as minimizing your waste and bringing your system up to maximum efficiency. You also want to minimize the leaks during storage and transportation of your chemicals through piping or anything like that. The more leaks you got, the more waste you have.
I think this was Jacqueline's slide. So one technique used in green engineering is analyzing your process flow diagram after it's made. You look at it to figure out ways to reduce pollution, so maybe some different recycle opportunities that could be used in your process flow, and then also how chemicals are going to react with the environment from what's being released from your process. So overall, you're just trying to find ways to reduce waste that is produced. One key part of green engineering is the economics behind it. This is a basic equation that sums that up. Looking at the incremental net present value and how it relates to your project cost and yearly savings. The project cost is how much it costs to build your process plus implementing different pollution prevention ideas. And then the yearly savings is how much you're going to save as a result of the pollution prevention thing. So here's an example of how this would work. I believe this is the Hooker Chemical Company. Before there were a lot of regulations in place, they followed everything that was in place at that time. So they just buried a lot of waste in a disposal site. Well, later on, homes and schools decided to use that to build on, and Hooker Company clearly told them not to because there's chemical waste under there, but because of regulations they were, I believe, allowed to. In the process of building there, they ended up causing a leak of that chemical waste, and health problems occurred. And even though regulations were not in place, I mean, Hooker was not violating any regulations when they disposed of it. They were held liable for the new problems that arose. So this is, I guess this is the precedent set that even though you might be following pollution prevention at the time, long-term economic policy, things might change. So it's good to, go above and beyond in terms of pollution prevention. And you also, it has an effect on the environment, it affects on people, and then, like I said, you might be held liable down the road. Another technique used is a life cycle analysis. This is, it's a technical study of the environmental consequences of the whole process from starting material all the way to products produced. So life cycle is considered starting with how the raw materials for your reactants are acquired. So you got to look at that part, followed by how they get from the raw materials to the reactants you're using. After that, it's looking at your reactants to the products you're making, and then how your products are going to be used and how they're going to be reused if they are, followed by how the product will be disposed of eventually, and then the equipment, how it's going to be disposed of as well. So the steps involved in a life cycle analysis: first, you have to define the boundaries that you're going to decide for your analysis. I mean, life cycle analysis can be as big as you want it to be, and you can look at how the still for certain tanks in your process line were made and how the environment was affected by making that still, and all the way down to the concrete, I suppose. So you have to decide what you're going to look at in your life cycle analysis, and then after that, you got to conduct an inventory analysis. Everything from raw materials all the way to products have to be inventory to know what's going to be made, kind of like a material balance. To that, you have to figure out the impact it's going to have on the environment, each of those materials, followed by how you can improve on the